I understand it now. Come on, guys. It's easy now.
See how useful it is to know how to launch objects at an angle? And you can learn that too. Let's take a look at solving angled projectile questions. Okay, so in the last video, we looked at solving horizontal projectile questions, such as the cannon shooting a cannonball off a ledge. And this was when the cannonball was shot completely horizontally. So if it shot at 10 meters per second, we could say its velocity in the x direction was that 10 meters per second. This was also made easier in that our velocity in y, the up and down, was 0. It's not going up or down. And that enabled us to put that 0 number into all of our y calculations for initial velocity. It actually made it easier. But today we're going to look at when we change up that initial velocity in y. And we can see in today's example that when we're launching a basketball, it's going both forwards and upwards. So we have a velocity initially in x and a velocity in y. And we're going to have to figure out what those numbers are so that we can do our x and our y calculations with the appropriate numbers. Whatever it's initially shot at, that number actually isn't useful. We need the x and y components. And I want to emphasize how important this step is, and it's the first step, step one that you should do before any other consideration of calculations. Even though there's a lot more coming up, I usually give a half mark for this when I'm marking it. So I tell my students, make sure to do this step at the start as it sets us off on the right foot. So the example we're going to look at today says a basketball is shot at 10.5 meters per second, but here's the angled part at an angle of 54 degrees. It lands in the hoop, the person makes the shot, and the hoop is 3.05 meters tall or above the ground. The 3-point line is 7.24 meters from the hoop, and we're trying to determine was the shot beyond the 3-point line, basically saying is it worth 2 or 3 points. So what should we do to start this question? As we just said, our first step is going to be considering that although that 10 meters per second, or sorry, 10.5 meters per second was given to us in the question, we're not going to use that number. We have to break it into our x and our y components. So it's not that hard to do. We're just going to use that angle of 54 degrees here. We're going to take sine to find our opposite and cos to find our adjacent. And that's going to give us 6.17 forwards and 8.49 upwards. So my initial velocities in y and in x. So with that first step done, let's move it over to the bottom there and now set up our calculations. Where to begin can be a little bit tough for these questions, but this is how I would probably think to start this one. I'm trying to figure out how far it is from the basketball to the hoop. So I'm trying to solve for a distance here in the x direction. So I'm going to start with my x and y at the top and initially look in x, and I'm trying to solve for a distance. In x direction, we're going to look at the motion. There's nothing accelerating it after it's shot. Once he throws the ball, it's going to keep moving in this x direction at a constant velocity. So our formula for constant velocity, v, is d over t. I think, perfect, I know the velocity, it's 6.17. All I got to do is my velocity times my time, but we don't have time. And this is a familiar problem that we had from horizontal projectiles. A variable that I'm missing is time. But fortunately, the time is the one variable that's going to be the same in the x and both the y direction. The time that it's moving in x is the same that it's moving in y while it's launched into the air. Let's look over to y and consider what formulas we have over there. Well, this y motion is accelerated because gravity is accelerating it in the up and down or the y direction. So we have a bunch of formulas to pick which one. We'll list all our variables for accelerated motion. VI, VF, A, D, and T. Let's see what we know. We know the velocity, well, it's not a question mark anymore, is 8.49 as we found this component. VF, we don't know how fast it's going when it goes in the hoop because it's at a higher point. So we know it's not the same as 8.49, probably a bit slower. Acceleration of gravity is always going to be 9.81, so we know that. And the displacement, it's going to end up 3.05 meters above where it started. Last variable, time, we still don't know that. That's the whole reason that we're over here. So I want to figure out time. I'm looking for the equation that does not have VF. So look on the formula sheet. What's got time and does not have VF is our equation D is equal to VIT plus half AT squared. And we kind of think, perfect, this is what we did in horizontal projectiles. Let's plug in for this. Let's try and solve for T. But then looking at the equation, look at this, we got T and we have T. There's 2 times to solve for it. Now this did happen in horizontal projectiles as well, but we got around it before by making VI 0, this whole term could cross out. But now since my VI is not 0, we can't use that trick to get around using a quadratic for this equation. Now, if you've done math where you've done quadratics, you can totally use that. But in grade 11 physics, you often don't have a prerequisite of doing quadratics in any math class. So we're not going to solve it that way. If you know quadratics, go for it. But we're going to try and go around it another way by trying to figure out a different formula to use, which is actually going to be using VF. So if I had VF, I could use a bunch of other formulas. So instead, let's just not use that equation and solve for VF first. Then I'm going to have more options. So let's figure out how fast it's going when it goes into the hoop. An equation then with VF and doesn't have t, because I don't know what t is VF squared equals VI squared plus 2ED AD from our formula sheet. So let's rearrange there, or plug in our numbers and take a square root is all we got to do for that rearrangement. Plug that in our calculator and I get a number of 3.5 meters per second. Which makes sense, a little bit slower, right? It went up, it's coming down, but it hasn't come down to the ground yet. It's going slower when it enters the hoop than when we launched it. Okay, so now I know my VF value, but just before we move on to anything else, we should actually consider what this number is, 3.5 meters per second. It was launched at 8.49, positive meant upwards, and when it goes into the hoop, it's going 3.5 meters per second, which means upwards still. That doesn't really make any sense. So we should always check in with the positives and negatives to make sure these values make sense. And you might go and you double check all your calculations and you're still getting positive 3.5 meters per second. How does that make any sense that it's going up when it gets into the hoop? You've actually done no calculations wrong, but just the nature of this equation can give you either a plus or a minus 3.5 meters per second because we took the square root here. And taking the square root always gives you a positive and a negative answer. Think if I take 2 times 2 is equal to 4. I could also take negative 2 times negative 2, which is also equal to 4. So if I was going to take the square root of 4, well, I have 2 things. I have either positive 2 or negative 2. Both of these multiply by themselves to give you 4. So anytime you take the square root, the plus or the minus works. So here it could be negative 3.5 or positive 3.5. We kind of have to interpret the question and say, actually a negative makes more sense here because we know that the ball is going to be going down. So when I go into my next equation, we're going to have a negative 3.5 there. Let's look for another equation now. I have VF, VI, AT, and D. I can use any equation. I think the easiest one is the first one usually on your formula sheet, which is A is VF minus VI over T. So we'll rearrange that, just switch out the A and the T, plug in our values, again, making sure to make 3.5 negative, and we get an answer of 1.22 seconds the ball's in the air for. It's actually a fair amount of time it was in the air, but until it leaves and hits the hoop, 1.22 seconds. And now finally, after all of that work, we're not quite done. The whole purpose of getting time was to bring it back into X, saying that if it's moving forwards in X for 1.22 seconds, I times it by my velocity in X, and we get a final distance of 7.6 meters. How does this answer our question? Well, we remember that the distance from the hoop to the 3-point line was this 7.24 meters. So our answer being 7.6, it is beyond the 3-point line, and this does count for 3 points. So our answer is that it's beyond the 3-point line for our final answer to this question. Now, for me, that's the most intuitive way to solve this because we're looking at, is it beyond or within the 3-point line? It's asking about a distance in X. But sometimes there's some other ways that you can solve it. And for this one, we could have solved for, well, how high is it when it has traveled that distance to the 3-point line? So just show you what that looks like here. We could start in X and say, well, V is equal to D over T, same thing that we started with before. But now I know the distance that it would have to go if it was at the 3-point line. And I know how fast it's moving forward from breaking into X and Y components. So let's see that if it was shot at that point, at the 3-point line, if it would have fallen short or if it would have been still above the rim at that point. So then we could say, well, it's going to take 1.17 seconds to go that distance to the 3-point line. Throw that into our Y here. Now I know a time, and I'm trying to figure out if it's above or below the rim. The nice part about this one is if I want to solve for D here, I can get rid of VF, and I actually can solve for this equation because I know time. So that one that I couldn't use before, I could use using this method. plug in, and I get a distance of 3.2 meters, saying that when, if we shoot it from the 3-point line, it's going to be above the rim here, then we must know that we shot it beyond the 3-point line. Again, that way is a little bit harder to wrap your head around, but in case you're wondering, is there other ways to solve it? Yes, there's some other ways you could do it there. And that's our conclusion for this video. So I hope that helped you to understand some angled projectile questions. Thank you so much for watching, and I will see you in the next video.